Thanks for the introduction. So, my name is Oron from Media AI team in Microsoft R&D. Today I'm going to talk with you about Video Indexer, a video indexing platform that's been developed in Microsoft from scratch in a rather unique program of incubation, which is somewhat like a startup within the enterprise. It was started in 2016 by a few of my colleagues, and nowadays being part of a large team of excellent fellows. We're going to skip through a quick 60 seconds video just to understand what the product is about.
Every company that has a large video library faces the same problem. Tagging videos manually is expensive and often leads to errors. Introducing Video Indexer. Using advanced AI technologies, this service can automatically extract metadata from any video, spoken words, printed text, faces, emotions, and more, helping clients easily search, review, curate, and publish much deeper insights from their content. Imagine being able to easily search specific people, find everything they said on a particular topic, even get a transcript translated to a different language, search street signs or words on screen. This advanced way of indexing video can be used to help customers build intelligent apps, such as deep search, personalized recommendations, automating video workflows, targeted video advertising. The possibilities go on and on. Video Indexer can efficiently help news agencies and sports broadcasters monetize their content, help retailers, manufacturers, and smart city tech providers easily improve their business insights at any scale you need. And speaking of flexible, you can use it without writing a single line of code, or embed it into your application using APIs. Want to see it in action? Sign up for a free trial with just an email address. Upload a few videos and see how this exciting new service can help get more out of your content now, only with Video Indexer.
So a bit of PR, but as you can see, we are indexing the video to extract all the unstructured data within and provide it via an API or a website. So back in 2016, Cisco forecasted that the video would be a business of over 200 exabytes of data by 2021. And also back then and till now, Microsoft Research has came up with various human parity on several challenges like object recognition, speech recognition, machine translation, and others. And so we took all of that in order to infuse those technologies into the video indexing problem. And so this session would include an overview of VI and in-depth of OCR in a video and meta-learning recommendations for custom face identification. The following chart explains in high level what we do from left to right on uploading a video to VI into the video index on the right-hand side, which is either a JSON file with all the semantics or some experience in the embedded website. You can see two channels of streaming. The first on the upper hand side is the audio, which includes multiple speech recognition challenges and later on NLP. And on the bottom, you can see all sorts of vision analysis algorithms to extract all the insights there. Both of them starts with transcoding into a standard waveform in which we analyze multiple algorithms. In this case, this bundle of algorithms handles the speech recognition. It starts with language identification, which is a task that takes the waveform as an input and extracts the spoken language out of 9 languages. It uses voice activity detection in order to filter out the non-speech part, and uses ResNet in order to classify the spectrograms within, find the patterns, and classify again one of 9 languages. Work done by Shai, which is here with us today, and give a talk later on. Next part relates to the transcription and translation of the spoken text. Now we know the language, and we provide a service that is based on ASR technology from MSR that uses deep learning in order to classify the spoken text into 11 languages, which is also available as machine translation of both the spoken text and other insights later on extracted through the process. One nice project that we use, also built in MSR, is custom speech recognition that adapts the language model in the ASR system with the customer's particular vocabulary. So we can upload natural text that has some specific jargon, and we learn how to adapt the language model in order to do a better job in finding the specifics in the speech. Next is a problem called speaker diarization. Speaker diarization means to take an audio stream and segment it according to the speaker IDs of the persons in the audio. It is an unsupervised problem solved with GMM over MFCC features, which are rather standard in the automatic speech recognition. Next task is emotion recognition. This work was done by Abed and Liron, which gives a talk later on, I think in the next slot, on how to take spoken utterances, both from the audio and the text, and classify it into 5 emotions, and later on fuse it together into some robust solution. In the vision part, we start also with transcoding the video into an MP4 file, and continue with the face recognition, which is rather complex bundle of algorithms. It starts with face detection. So we got a video and we need to track all the faces across the entire video and see the exact times in which they appeared. We use Cognitive Services API in order to solve that, an algorithm by MSR, Microsoft Research. And this API can also extract various attributes of the face, like head pose, whether this person wears sunglasses, and many other facial attributes that we'll get to later. The next part is the face grouping. So we need to cluster these all segments together according to the person behind it. Out of each of those faces, we want to extract the one face that looks best in the most frontal-facing pose. So this is another task in order to extract the best thumbnail out of this collection per person. The next obvious task would be the face identification. Here it is a 2-part algorithm. So the first one classifies one of 180,000 celebrities in an out-of-the-box model, which is soon to be scaled up to 10 times that number and more. And the second would be to customize the face recognition model for identifying persons that are not celebrities. So in this case, we also use a model by Microsoft Research that does transfer learning from a large model in order to be able to teach the face identification algorithm to classify given a single image. It could be more than that, but it could actually work from one image only. So I actually did not prepare this after the game, but I was lucky enough to have Gareth Bale to score twice in the final. But We can see here the UI of Video Indexer. Here is an interview in Spanish that was recognized by our system, and that's how the website looks like. In the right-hand side, you can see the people found in the video. So Gareth Bale was recognized as a celebrity, and we show its biography. But the interviewer, which found to be unknown, as you can see, is Alfonso Torres, which is some interviewer in some sports channel in Spain. But we are enabling our customers to edit his name, and we take behind the scene all the segments in which he was seen at and train a new face identification model for Alfonso Torres. So why is that important? And what problems does it raise? So imagine customers like surveillance facility for a bank in some multiple branches. In this case, some bank asked us to identify 1,000 employees out of surveillance camera. Also, Channel 9, the broadcasting channel of Microsoft, having multiple engineers telling about the new features. They want to index their videos according to the faces found in them, and many others who need this capability in large scale. It raises a problem where some super user would like to be able to manage those faces and the quality of the model he trained in some proper manner, and we would like to provide him this transparency. So this raised an ask for upload image, and to be able to boost confidence of models, giving some data set that the customers have. And so in order to do this, we wanted to be able to optimize the way we ask the customers to select the set of images that best improve the confidence. And we build a model that classifies does regression for the confidence of the face recognition model. We see that in a bit. But in the graph you see before you, you can see training sizes of 1 to 9, calling to this API and testing with the following confidence. And you can see that adding a random image for the training set boosts the confidence of the model by about 1.3%. And we wanted to help the users do better than that. We call this problem meta-learning recommendations for custom face identification. And we'd like to take an image set and both extract the expected confidence with regression and extract recommendations that can help these customers boost their confidence going forward. We took sets of 1 to 10 images as training set and tested those on top of labels of a test set after training the face identification custom model. These gave us accuracies and confidence per sample. And each of those images in the training set was extracted with the face detection API in order to extract multiple attributes from the face, like the emotion, the head pose, the blur in the image, and other stuff that can be translated into textual recommendation. We've aggregated these features and mapped ourselves the path from these aggregated features into the extracted confidence by the face identification model, and hence the meta-learning. The features that we used were features like train set size, facial expressiveness, head pose, occlusions, and other features, which sum up to 17 features, not much, but it was able to do fairly well with random forest regression trees. And after we yielded the tree, we can extract some information from the predicates in the nodes in order to do some recommendation with respect to that. So if we'll take a part of a tree, and we got the root and the leaves containing the values that we'd like to optimize. And we do have a single set of per person training set that the user uses. And in this case, the expected confidence could be some number, like in this case, 55.4%. And so we'd like to find some candidates that replace that. So the alternatives would be the one with higher expected value, which is the confidence. If we'll take all the branches that leads to better result per tree, we can ask ourselves which predicates satisfy by the given set and which doesn't. And we can later on rank the results with respect to the expected confidence divided by the number of unsatisfied predicates in this branch. This case would get the highest confidence with rather few changing that this user needs to do with our recommendations. This work is still in research, but the accuracies are RMSE of 4.75% for the random forest in general, and the recommendations were found to boost over the random simple addition of an image by almost 20%. So the overall experience, which is not yet in the product, but would look something like that. The user would see multiple persons, and per person, he can see the expected confidence, and even click this and get all of the samples that we extracted either from videos or from images, and a set of textual recommendations like upload images without occlusions and upload these to boost the confidence of his models. Back to the graph. So another cool feature is also by cognitive services. It's called labels, which does basically object recognition and scene understanding and extract those in textual manner. And one other model that I'd like to discuss deeper is the OCR, Optical Character Recognition, which takes the entire video and extracts and consolidates the strings within that appear visually. This work was first done by some sister group in Microsoft, which actually took some OCR technology that extracts OCR from an image and asked the users to give it some sampling rate in order to sample all the frames and extract the OCR elements. The problem that you can think of yourself is that this leads to rather challenging results, as some text might appear in multiple variations through the video, like the example we see now. It could be watermarks, font variation. We can have a different alignment of the text. It could be in multiple languages. It could not be in English, like CLE for Cleveland. It could be written text, or it could be a transition between multiple frames with different text. So, and many others, all of these lead to a challenge that we need to handle. And we took an approach of a two-step algorithm. The first would be MSA, multi-sequence alignment, which is taken from bioinformatics. And the second is consolidating the results later on the entire video. So MSA is actually having a rather simple hypothesis in this case of the OCR. If we'll cluster the entire text appearing in the video, then the same underlying word would probably have multiple variations, but if we'll take a single letter and align it with all the other results, then we probably get the correct classification across the entire video, like a $ that might appear in Microsoft, but later on appears most times as a correct form. In order to boost the confidence of some unexpected cluster, we also use the transcript. So it is an evidence from a different channel in order to boost the results. The next part is the consolidation, in which sometimes we can, although we have the MSA solution, we might have some different permutations of the same text still. So in this case, we see 2 slides from a deck on a video that someone uploaded, and it extracts a list of text that appear in this frame. And so the order of these words might not be aligned, and also some words could disappear from one another. So we need to solve this matching problem and identify which word was disappeared. And in order to do that, we modeled that as an assignment problem and solved it with the Hungarian algorithm. And we took basically the text that appear in one frame against the text appear in the next frame, and measured the distance, the binary compared distance with the Levenstein or edit distance. The algorithm basically minimizes the sum of some decision binary variables that needs to be summed up into exactly 1 over all the rows and all the columns. This essentially gives us a robust solution, like you can see here. If you'll see the Lionhead Studios watermark, which is mapped into all of these sequences, is consolidated eventually correctly. We selected some error measures against a basic naive solution, which just applies edit distance in order to consolidate terms. And we've seen a dramatic improvement going with the new alternative. As you can see, some of them are consolidation false positives, text detection false positives. And I didn't mention, but we also do some language detection improvements with reducing long tail appearances across the video. So we got to the NLP part, which has multiple algorithms, but I select 2 of those. The brand detection is super valuable to our users, and it basically solves the disambiguation problem from Apple into apples. As you can imagine, that appears sometimes in a text, but given the context, can be super helpful for recommendations and monetizing apps with video. We support currently 92K brands, and provide it also in customizable model, which user can adapt with his own data. The last algorithm that I'd like to discuss is keyword extraction, which basically takes the transcript spoken in the video and the visual text from the OCR and extract the centrality of different terms seen in the video or the text with explicitly mentioned terms within the video, which is also valuable into indexing. So, to summarize, I wanted to think of some takeaways from this talk as I was addressing rather the overview of the product. And one thing that was very strong for me in person was the collaboration we experienced on the entire company. And I know many guys are here from Intel and other enterprises, and probably know what I mean when each team has its own agenda, but relying on shoulders of giants and collaborating together can actually lead to some cool features. Another thing that was a takeaway is multi-channel algorithms that takes like the motion recognition, both the audio and the text, and both OCR that uses transcript in order to boost accuracy. We all the time trying to get the models more complex and rely on more channels, which is also challenging but yield better performance. And lastly, the UX in this product has managed to support us in both helping in labeling by customers their own customizable algorithms in order to do better face identification, in order to find their brands, etc. And also this face meta-learning challenge, which was rather different than all the insights because it's aimed at a better experience eventually. So give it a spin in video AI. And thank you so much for your...
Thank you, Oron. So we have time for questions.
Thank you very much. Pros and cons versus media platform, Watson media platform, basically doing some sort of resemblance.
So in video platform, do you mean like Azure Media Services?
The Watson media platform, where they use voice and image to build automatic metadata. So how is it different from that?
So we basically solved the indexing problem, helping users. We're a B2B customer. And we'd like to help others index their video best and help their clients identify the insights, the non-trivial insights, which could also include some difficult queries like find me the videos where Donald Trump was spoken in a positive sentiment on the US Embassy in Jerusalem and stuff like that. We're going towards the query capability, but you currently can query those on top of the already structured data by us. And so our customers could be media platforms, it could be hot VOD, it could be TV channels with large data set that their editors want to search. It could be, we support, forgot to say, 60 languages in the machine translation. So this is relevant to quite large audience. There are other like surveillance and stuff like that that we're going forward in order to build some robust solution for those segments.
Thank you very much. It was very interesting. You mentioned maybe in the last sentence, for new application, let's say I want a video of traffic and I want to detect near accidents. Will that be an incremental change over this, or does one need to start from scratch for these kinds of analysis?
So this is a more complex question, since you want to first identify what are near accidents, right? And so this is a pretty specific problem that you're addressing. It is less relevant for facial recognition, speech recognition, and other solutions that we do provide, but you can in fact take that and spin it off against recognizing street signs and other types of written text or spoken text.
Okay, we have time for the last question.
Thank you for the presentation. I'd like to ask, just now you mentioned that there are certain pictures that whereby you are not able to identify the software, and then it will result in an unknown, right?
Yes.
What is it that your team is doing now to solve that, and is it possible to use web scrolling to solve that?
So, as I mentioned, there are two types of face identification models in VI. The first is the celebrity recognition, which handles currently 180,000 different faces of celebrities, and should be boosted into a couple of millions soon. The second is the customizable face identification problem, which provides the customer, the end customer, to upload both videos and images in order to teach a new model how to recognize Alfonso Torres or my little boy or any who is not yet a celebrity. Does that answer your question?
Yeah, like, is it possible to do a web crawl, for example, of Facebook and identify that?
Well, I can't answer this over this podium, but if the legal allows you, then you probably can.
Okay, so let's thank our speaker again. Thank you, Oron.